4 from the quiz. All right. Through how many degrees does the minute hand of a clock rotate in 2 hours and 15 minutes? Okay, so we know that the minute hand of a clock takes, it does 1 revolution, or 360 degrees, in 60 minutes. And then you want to take that, and we want to know how many degrees does it do in 2 hours and 15 minutes. So if you convert those all to minutes, 2 hours would be 120 minutes, so that's 135 minutes total. Since 2 hours is 60 times 2, and then plus the 15, so 135 minutes. So you'll just take 360 degrees. It takes 60 minutes to do it, so that's its rate, that's its angular velocity in degrees per minute. And then we want to multiply that times 135 minutes. That's like over 1. The minutes cancel, and so you're left with just degrees, and you should get 810 degrees. What else? I forgot my darn calculator. Poop. Page 176. Number 1. All right, so it says find the degree measure of an angle formed by 1/6 clockwise rotation. And we want degrees. All right, so clockwise means it's going to go this way, so a negative angle. And so we'll go 1/6 times a negative 360 degrees, and that'll give you negative 60 degrees. And so it's to here. That's 1/6 of a clockwise rotation, or negative 60 degrees. I guess I could have written it as 1/6 of a revolution, and then you're converting it to 360 degrees in 1 revolution if you want to, and so the revs cancel. You want negative because of the clockwise, so clockwise tells you it's going to be a negative angle. Clockwise is a negative angle. And then counterclockwise is going to be positive angle. Find a question for me to do, Todd, and I will do it. Page 178, number 12. Okay, so they want you to verify the identity. And how it will look on the test is without things plugged in. So I'll write it how it'll look on the test. It'll look like verify the identity of 1 plus tangent squared of theta is equal to secant squared of theta. So we know this is true, right? I tan in a second. And they want you to prove it for when theta equals negative pi over 6. That's what it'll look like on the test. And so you'll plug in negative pi over 6 into the left-hand side. And then you're going to square that. And then secant of negative pi over 6. And then you'll square that. And this is what you're proving. You want to verify that it's true. All right, so negative pi over 6 means that you've gone clockwise, and that's 30 degrees, right? So that's a rad 3 over 2 and a negative 1/2. So tangent is going to be, I should have drawn it bigger, whatever. All right, so negative 1/2 over rad 3 over 2, which means that it's negative rad 3 over 3 once it simplifies. All right, so we've got a 1 plus negative rad 3 over 3 quantity squared. And is this equal to, secant is 1 over cosine, so that would be a negative 2 quantity squared. No, dumb. Let me go back. 1 over cosine is not, come on, I just did sine. 1 over cosine would be a 2 over rad 3 quantity squared. All right, so we've got this would be a 1 plus a positive 3 over 9. And is that equivalent to a 4 over 3 once you simplify it? And then this is, to get a common denominator, you would make this like a 1 over 1 and go times 9 and times 9. And so this would be a 12 over 9. Is that equal to 4 over 3? And if you divide top and bottom by 3, you would have 4/3 on the left and 4/3 on the right. And so that's how you're going to verify that that identity is true for negative pi over 6. All right, page 123, number 47. Okay. What is the measure of the degrees of the smaller of the two angles formed by the hands of the clock at 3:15? Okay, so you got this clock, and here's 3 and 12, and here's the center, and 1 and 2, and 4 would be there. Okay, so at 3:15, your minute hand, the long one, is pointing directly at the 3, but then the hour hand has moved just a little bit away from the 3. And this one's actually one of the easier ones to do. So all you got to do is figure out is how far, because at 3 o'clock, exactly, the hour hand, the short one, was on the 3, right? But it has moved 15 minutes worth, right? And it takes the hour hand 1 hour or 60 minutes to go from pointing at the 3 to pointing at the 4. So it'll take 60 minutes to do it. Now, and the angle between the 3 and the 4, angle between the big numbers, between 3 and the 4, is 30 degrees. That's true of every single one of these big numbers. It's 30 degrees in the whole thing. So we've got that the hour hand will move 30 degrees in 60 minutes. but we've only traveled for 15 minutes because it's 3:15. So it's only 15 minutes out of the 60 minutes that it'll take to get there. And so you should get 7.5 degrees. 30 divided by 4, 7.5. All right. I already did number 4 on the quiz. That was 123. Okay, page 124, number 34. 120. 124, number 34. Okay. Horology is a science, blah, blah, blah. Through how many degrees does the minute hand of the clock rotate in 3 hours and 45 minutes? So, minute hand, how many degrees? Number of degrees in 3 hours and 45 minutes. Okay, so we know that the minute hand does a full 360-degree revolution, right? Or it makes a full circle in 60 minutes. And then we want to know how many degrees in 3 hours and 45 minutes. So 3 hours would be 3 times 60, which is 180, and then plus the 45 minutes to convert these to minutes. 180, so I think that's 225 minutes. Check my math because I don't have my calculator on me right now. 225 minutes, I believe. And that's over 1. And so, what would that be? 6 times 225? I don't have a calculator. 1350? 1350 degrees. That was 124. Number 34. Number 4 on the quiz I already did. Page 131, number 32. The minute hand on a clock is 11.5 centimeters long. How far does the tip move? So how far does the tip move is arc length. And it's from 4 to 4:15. So at 4 o'clock, your minute hand, whoops, I should have. There. Okay. 4 o'clock, you're right there. And at 4:15, so that's at 4 o'clock, and at 4:15, here's the 12, and here's the 3, and here's the 4. Your minute hand is now pointing directly at the 3, and then the hour hand is like that. All right, so the minute hand went from being pointing right at the 12 to pointing right at the 3. And so the minute hand went from pointing straight up until pointing directly that way, and so it has moved that far, which we know is 90 degrees. All right, so it moved 90 degrees. That's the angle. We want how far, and what that's asking for is arc length. We want this. That's how far it moved. How far is that red part? All right, so that's arc length. Sur theta, S equals R theta, where your theta must be in radians. All right, so your radius, the minute hand is 11.5 centimeters long, so that is your radius, 11.5 centimeters. And then you're going to multiply that times 90 degrees, but in radians, that would be pi over 2. And I don't have my calculator. You you should get 18.1 centimeters. Let's see if that makes sense. 2 goes into that, 5-ish, 5 times 3, yeah, that should be about right. Hopefully, if you put that in your calculator, 11.5 times pi over 2. Page 178, number 6. A point on a wheel, 10 centimeters from center. So if here's your wheel and here's the center and it's saying it's 10 centimeters away, that's your radius. They gave you this 10 centimeters. It moves through an angle of 315 degrees in 1 minute. And determine the linear velocity of the point in, we want centimeters per second. All right, so linear velocity is vroom vroom. V equals r omega, where omega is your angular velocity, but in radians. All right, so your radius is 10 centimeters. So I got 10 centimeters, I'll write it over 1. Angular velocity, that's what they gave you, an angle over time. So 315 degrees in 1 minute. So 315 degrees in 1 minute. But you've got to change this degrees to radians. One thing is the fact that it's centimeter degrees per minute, which doesn't make any sense. So, and remember, radians is dimensionless. So you got to do a conversion of changing the degrees to radians. Since I've got degrees on the top up here, then I need degrees on the bottom, and then I'll have radians up top. And how they are related is there are 180 degrees in pi radians. So now your degrees cancel. Radians is dimensionless, so you get to ignore that. And right now I've got it in centimeters per minute. You got to do one more conversion, and that's to change minutes to seconds. So minutes is going to go up top since minutes is in the bottom there, and seconds on the bottom, and there are 60 seconds in 1 minute. And so when you go 10 times 315 times pi divided by, careful now, so when you put it in your calculator, you'll go 10 times the 315 times the pi, and then you want to go divided by, and either parentheses and then the 180 times 60, or you could go divided by 180 and then divided by 60. But either way, you got to let your calculator know that both of those are in the denominator. And you should get 0.92 centimeters per second. It's page 178, number 6, number 8 on the quiz. So that's very similar to the one I just did previous. When they ask you how far does the angle move, how far is a distance, and that is arc length. So they tell you that the minute hand is 3 1/4 inches long. That's your radius of the minute. If the minute hand is that long, that is the radius. How far does the tip move? That's arc length. Sir theta. And between 9:45 and 10:30. All right, so at 9:45, your minute hand is pointing directly at the 9. That would be 9:45. And then at 10:30, our hand is moving too, but the minute hand would be pointing down at the 6. And so we want to know through this angle here. And so that theta is 270 degrees, but you've got to change it to radians, which is 3 pi over 2. And so your arc length, and by the way, here's it. when they're asking how far did it move, they're asking this distance there, which is your arc length. All right, so we've got 3 1/4 inch, which is 13/4 of an inch, and we're going to go times 3 pi over 2. And it said to round to the nearest tenth, and so we've got 15.3 inches. I cannot go over every single test topic. I can try. You give me questions and we can do it. Page 124, number 36. So they want through how many degrees does the second hand, now when they say second hand, it truly means the second hand, not the minute hand. We're talking about the ones that moves around the clocks every second. Okay, so how many degrees does it rotate during a 93-minute movie? Okay, so the second hand goes 360 degrees in 1 minute, right? The second hand is the one that goes tick, 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 and it takes 60 seconds for it to go all the way around, or 1 minute. And then we're going to take that 360 degrees, and in 1 minute, that's the angular velocity of the second hand, and we want to figure out how far does it go in, or how many degrees does it turn in 93 minutes. So minutes cancel, and when you multiply those, 360 times 93, you should get 33,480 degrees. Hopefully, yeah. All right, that was that one. Can you clarify what answers, but always be put in radians? Okay. So, when you do arc length or linear velocity, got to be in radians. Got to be in radians. The other time is if, well, it's usually in doing these problems, so it shouldn't be an issue, but if you need to get rid of revolutions, or you need to get rid, like the word revolutions or the degree symbol, you're going to make it radians, and then radians are dimensionless. And so, like if your final answer needs to be like in centimeters, having your angle in radians is what's going to make it just in centimeters. Page 178, number 2. Ooh, sorry. 178, number 2. We want 218 degrees, 18 minutes, and 46 seconds into decimal degrees. All right, so this one you can do in one step. It's 218 degrees plus 18 minutes. There are 60 minutes in a full degree, and then 46 seconds. There are 3,600 of them in a degree. And so you can put that straight up in your calculator, and it should give you 218.31 degrees. It's because you can think of it, I mean, I can show you more work than this. It's because you've got 18 minutes, right? And then you're multiplying it times, you want degree on top, you want minute on the bottom, and there are 60 minutes in 1 degree. So that's what we're doing, and then the minutes cancel, those units cancel, and you're left with degree. And then there are 3,600 seconds in 1 degree, and so that's why we do 46 seconds, and you're multiplying it times. In 1 degree there are 60 minutes, and then there's 60 seconds in a minute, and so 60 times 60 is the 3,600 seconds. And so now those seconds little symbols will cancel there because it's like over 1, that's like over 1, and so your symbols for, you know, this guy cancels and that guy cancels, and you're left with just the degree. And this one, the second symbol cancels with that one, and you're left with just degrees. And so that's why these guys are now degrees, and now those are degrees. And so then putting in your calculator will give you the decimal. And you do have to show that work, right? In the directions it says show work, so I don't just look at that answer blank of 218.31 degrees. I actually look to see, did you actually know how to convert it? Because otherwise you could just put it in your calculator and be done. It would be too easy. Page 174, number 33. All right, we got 1 minus cosine of theta over 1 plus cosine of theta, cosecant theta minus cotangent of theta, quantity squared. Okay, so I think what I would do is multiply. I would work on the left-hand side. And remember, with these proving or verifying identities, you're going to work on one side and one side only. And so I would start on this left-hand side, and I would multiply by the reciprocal of the, not reciprocal, the conjugate of the denominator. So multiply by 1 minus cosine theta. That, and then that will give me a 1 minus cosine theta quantity squared, because the tops, those two guys are exactly identical. On the bottom, I've got a plus b times a minus b, which is a squared minus b squared. So 1 squared minus cosine squared. And because of the Pythagorean identity, then this becomes sine squared on the bottom there, like that. Well, technically, this is a 1 minus, because you got a squared on top and a squared on the bottom. So it's like 1 minus cosine over sine quantity squared. And then you can separate this. 1 over cosine, or I'm sorry, 1 over sine is cosecant, and cosine over sine is cotangent. And then that's quantity squared. Boom, done. All right. How is that one? Fix that. Okay, can you do number 3 on the quiz? We got 107.42, and we want to convert it to degrees, minutes, seconds. And again, show work. Just because you have the right answer does not mean you're going to get credit if you don't have any work. I won't give any points if you just have an answer without showing me work. But this is all you got to do. You're going to take it's 107 degrees plus 0.42 of a degree, and I want to convert that to minutes. And so there are 60 minutes in 1 degree. I mean, technically it's like this, if this helps you make sense of it. It's like this is 0.42 of a degree, and then it's like 60 minutes in 1 degree, and so now your degree guys cancel, and so now you've got minutes there. So this would be 107 degrees plus 25.2 minutes is what you've got there. And then that means I've got 25 whole minutes. 25 whole minutes. And then what I need to do is figure out, I've got 0.2 of a minute that I want to then transform to seconds. So I got seconds and a minute, and there are 60 seconds in 1 minute. And then that makes it to where these minute guys will cancel, and you'll be left with seconds. Again, you don't have to show the over 1. I'm just showing you why we're multiplying it by 60 minutes first, and then you take the 0.2 of a minute and figure out how many seconds are in that minute, 0.2 of a minute. So you get 107 plus 25 minutes plus, what is that, 12 seconds. And then don't leave your plus sign there. You got to just write it. 107 degrees, 25 minutes, 12 seconds. That's your answer. Okay, thanks, Preston. Yep. Put it in the minutes by multiplying by 60, then you get a decimal, and you do the process again until you have whole numbers. Yes. Number 5 on the quiz. So we want to determine the angle coterminal. Whoops, number 5. Coterminal angle with the 23 pi over 6, and where it's between 0 and 2 pi. So here's, I mean, really, you can just start subtracting 2 pi's, but I'll show you what I mean. 23 pi over 6. If I went around 1 time around the circle, that means this would be 2 pi. 2 pi over 1, to compare it to over 6, that means it's a 12 pi over 6. And then if I went around again, it would be another 2 pi, which would be another 12 pi over 6, so that's a 24 pi over 6. So going twice around the circle is 24 pi over 6. And so 23 pi over 6, I've stopped short. All right, and so all you got to do is go 23 pi over 6 minus, just subtract 2 pi, right? And that's like over 1 and times 6 and times 6. So it's a 23 pi over 6 minus 12 pi over 6, which will give you 11 pi over 6. That is the angle that would be coterminal and also between 0 and 2 pi. Page 157, 43. All right, so they tell you theta is between 0 and 4 pi. That means you're going around the circle twice. Find all the values for theta in which tangent of theta is equal to -1 and sine of theta is less than 0. Okay, so when is tangent of theta equal to -1? Well, remember, tangent is sine over cosine, and the times when it's equal to 1 or -1 is the 45-degree angle, or pi over 4. But it's negative here in quadrant 2, so this is 3 pi over 4. And also, it's negative here at 5 pi over 4. So this is when, so if you were ignoring the whole sine of theta is less than 0 and just answering it for when is tangent of theta equal to -1, and if you were on just one revolution around the circle, so from 0 to 2 pi, your answers would be 3 pi over 4 and 5 pi over 4. But the fact that they gave you sine of theta is negative means you're going to ignore this one because your sine is positive there. Sine of theta. Why did you freeze? You froze on me. Why did you freeze on me? Uh-oh. Oof, oof. Come on. Okay. Sine of theta is positive right there. So that's why we're going to ignore the 3 pi over 4. And so 5 pi over 4 is on one revolution around the circle. You're going to get an answer of 5 pi over 4. But the fact that it says between 0 and 4 pi means go around twice. You're going to do 2 revolutions around the circle, which means you're going to say it also happens at 5 pi over 4 plus 2 pi, which would be like, what, 8 pi over 4. So 8 pi over 4 plus 5 pi over 4 is 13 pi over 4. And so your answer is 5 pi over 4 and what the frick? It's not 5 pi over 4. Sorry. Doo-dee-doo. We're going to just pretend like that didn't happen just now. Go away. No, don't do that. All right, trash it. Okay. Let me select that again. That's not 5 pi over 4. 5 pi. Oh, you mother effer. Okay, I want this one. No! It's not letting me. Ignore that. Okay, I'm just gonna cross it out. It's gonna look ugly. 5 pi over 4 is in quadrant 3. This is 7 pi over 4. Like a dingleberry. I said it was 5 pi over 4. And so I'm gonna do that. Trash that one. Yes. There we go. Okay, and then trash that one. Sorry about that. Okay, and then when you add 2 pi to 7 pi over 4, you're adding 8 pi over 4, which is 15 pi over 4. So your answer is 7 pi over 4 and 15 pi over 4. Sorry about that. Yeah. So, okay. Was that 157 over 43? Okay. Page 169, number 13. All right, this is just like what we did, except, oh good, it does give it to me, okay. So when it says verify the identity, oh my god, this is exactly the same problem we did, but with exact values on the last one. I'm verifying that secant squared is equal to 1 plus tangent squared when theta is equal to 239 degrees. So the only difference here is you got to use your calculator, but you'll go secant of 239 degrees, and then you're going to square it And we want to know, is that equivalent to 1 plus tangent of 239 degrees? We better get it true, because I know I tan in a second, right? So we better get it true. The secant, you need to put in your calculator 1 over cosine of 239 degrees, and then square it. And this guy is still the same. You can hit tangent. Make sure you're in degree mode on your calculator. Make sure you're not in radian mode right now. Degree mode, and it should have been, if the book doesn't have a typo, this should have been a negative 1.9416-ish squared, and this should be a 1.6643-ish squared, and you should have gotten that they both end up being 3.7698. 3.7698. Check. I have done ones where I did do examples where you found the angle between the minute and the hour hand. If you want to find another one, you can look through the book and find me one. Page 132-47, but I have done it, didn't I? Yeah, I did one. Page 132, number 47. An angle in standard position whose measure is negative 7 pi over 6 undergoes a 4/3 counterclockwise rotation between 0 and 2 pi. Wait, no. Okay, rotations. Determine the measure of the angle between 0 and 2 pi that is coterminal with the resulting angle. Okay, so we want negative 7 pi over 6. Well, that means you're going this way. This would be a negative 6 pi over 6, and so negative 7 pi over 6 would be right here. Because I know the negative x-axis is like negative pi, and then over 6 would be negative 6 pi over 6. So we've got this guy, and then if I'm going to take that and do 4/3 of a counterclockwise rotation. All right, so now I'm going this way, and 4/3 of a rotation times, I want to convert that to radians, so that would be, in one rotation, that's 2 pi radians. All right, so what is that? 8 pi over 3 radians is going to be what you're adding to negative 7 pi over 6. I'm going to be adding, and counterclockwise, so we're going positive direction of 8 pi over 3. Get a common denominator, so 16 pi over 6 minus 7 pi over 6 will give you a 9 pi over 6. And 3 goes into both of those, so 3 pi over 2. Yeah, will be your angle between 0 and 2 pi that is coterminal. So what that's saying is, if you take this and you do a 4/3 of a counterclockwise rotation, your angle will come here and be straight down. Yeah. All right. 125, number 46. Okay. What's the measure in degrees of the smaller of the angles formed by a clock at 6:12? All right. So, 1, 2, 3. Okay. Now, and then here's the 7. So 6:12 means that your minute hand is pointing, whoops, there. Your minute hand is pointing there. And then your hour hand is no longer pointing directly at the 6. It's kind of moved past it a little bit, but we don't know how much, right? And so I think this is the exact same one that's in the example in the notes. And I know we do that, and all right, whatever. I'll do it the same way. Okay, so the minute hand at 6 o'clock exactly, the minute hand would be straight up pointing at the 12, right? It would be here. And so how far did this move? Well, it took 12 minutes. It has been 12 minutes, and each one of those little tick marks, each of the little minutes is 6 degrees. So each little tick mark, the smaller tick marks, how about if I call them the minute tick mark? Each minute tick mark is equal to 6 degrees. Yeah, each minute, each of those little guys is worth 6 degrees. And so it has gone 12 minutes times the 6 degrees to be that this is 72 degrees in here. So the minute hand from being pointed right at the 12 until pointed at the little 12-minute mark has gone 72 degrees. Now what we need to do is figure out how far has the hour hand moved. The hour hand moves from here to here. It moves from the 6 to the 7. It takes 60 minutes to do that. And it moves 30 degrees in 60 minutes. That's its angular velocity in degrees, right? So it takes 30 degrees because in between the big numbers is 30 degrees. You could also count like each of these little tick marks, there's 5 of them in between, and if each of them are worth 6 degrees, then, 6 times 5 is 30. So our hand does 30 degrees in 60 minutes, but it's only been 12 minutes. So you'll do 30 degrees in 60 minutes, and we'll go times 12 minutes, since it's 6:12 over 1. The minutes will cancel. And what is that? 1/2 times 6. So it has moved 6 degrees. Yeah. And that is, I wish I would have drawn my picture bigger. But that is from being pointed straight down at the 6. It's how far that guy has moved right there. That is 6 degrees there. All right, so to figure out how far, the angle in between, what we know is that the angle here between the minute hand and it pointing straight down at the 6 that's a supplementary angle. So this guy is what, 180 minus 72 degrees, which will give you 108 degrees. And putting these two guys together, adding up these two, will give you your final answer of the angle between the two hands. And that is 108 degrees plus the 6 degrees will give you 114 degrees. trying to think if there's a better, faster way to have done that. You still got to figure out how far this hour hand is moved. Otherwise, this would be an easy problem if you didn't have to figure out how far the hour hand had moved. If you figure out that's 6, what else could you do? You could just add up the little tick marks of the minute hand, but anyway, all right. Hopefully that helped. We've done a couple of these now, so check back into the other parts of the video if you're still confused on it. Number 15 on the quiz. Okay, so what is a reference angle? Reference angle is the positive, it won't ever be negative, acute, it means less than 90 degrees, angle that it makes with the x-axis. But you also, a reference angle, you need to match whatever is given, meaning degrees or radians, right? If I give you degrees, then your reference angle is in degrees. If I give you radians, then your reference angle is in radians. So number 15 was finding the reference angle for 215 degrees. So I would draw it 215 degrees. You would go this way. That's 90, 180, and then plus another like 35. So there's your 215 degrees. And so this angle here is your reference angle because it's to the x-axis. And so your reference angle will be 215 degrees minus 180 degrees, which gives you 35 degrees. So number 16, it's in radians, and so you've got to answer, your answer should have been pi over 6. You have to give a radian answer, not a degree answer. What else? Did I catch up with your list already? That was fast. Oh, I did. Talk to me. What other questions do you have? Are you guys still with me? All right, I see some typing. You got me for, what is it? You got me for about 7 more minutes. All right, page 123, number 45. Okay. So it says a certain 78 RPM phonograph. Do you guys even know what a phonograph record is? Oh, geez Louise. All right, so we got way back, a very, very long time ago, there were records. Oh my goodness. That was, records were before, so you guys do it digital. Before that, it was CD-ROMs. Before that, it was cassette tapes. Before that, it was 8 tracks. And before that was records, vinyl, you know. And of course, true musicians and stuff really love the vinyl records and stuff. But so hopefully you guys do know what they are. But oh my gosh, that's so sad. Okay, so 78 RPM phonograph record has a playing time of 3 minutes and 3 minutes and 32 and 1/2 seconds. through how many degrees does it rotate during its playing time? So 78 RPM means 78 revolutions per minute. We want to convert that to degrees, but we also want to convert this to, we need it 3 minutes and 32.5 seconds. Personally, I find it easier, unless it is super nice. The 32.5, ew, is ugly, so I would convert it all to seconds. So this would be what? 3 minutes times 60 seconds plus 32.5. So it's a total of, what, 180, 212.5, I believe, seconds, just to get it all to be the same unit. And then we want how many degrees. So you got to change revolutions to degrees. So you got rev on the bottom, degrees on top. That's 360 degrees in 1 revolution. So revs cancel, and then you need to convert the seconds and minutes. And so I got seconds on the bottom, minutes up top, and that'll give me, what, there are 60 seconds in 1 minute. And so seconds cancel, minutes cancel, and look, all you've got left on top is degrees, and you have no units on the bottom. And so when you multiply all this through, as long as I didn't make an error, the book says, and I don't have my calculator, sorry, hopefully it's correct, 99,450 degrees is what your answer should be. So this is just a straight up like RPM times however minutes it's been playing, and then converting to, they wanted your answer in degrees. Okay, so that was that one. Find a pendulum question for me. I have no clue where they are in this book. But if you find one, I will do it. Oh, good. Yay. Thanks to Riley. Riley found one. All right. We got page 130, number 18. All right. A pendulum of length 1.8 meters. So a pendulum goes and, you know, here's like a pendulum, right? And then it swings back and forth like this from its like thing. And so if its length is 1.8 meters, that's its radius. And so it travels through an angle of theta degrees, and its tip travels. Now the tip travels 2.6 meters. What they gave you there, and they want to know what's theta. Theta equals what? Okay, tip travels is arc length, which is S. Right, so here they gave you 2.6 meters, and then I'll just do this, and then I'm calling this theta. Right, so you use Sir theta, and your arc length was 2.6, and your radius is 1.8, and then times theta. And so theta, you're going to divide 2.6, that's meters, divided by 1.8 meters. And so your theta is 1.44, and then there are no units, right? Meters canceled, which means that this answer is in radians. Did it say? It wants 8. Your book gave it in radians, even though I take it as degrees. I would convert this to degrees, but I don't have my calculator on me, so I can't do it right now. All right, so 1.44 radians, and if you needed to convert it to degrees, you just multiply it by 180 over pi. All right, that was 130, number 18. Is that it? Got me for like 1 minute. If you wanted degrees, you would go the 1.44, well, actually you would do the 2.6 divided by 1.8, and then go times Oh, you're acting funky again. Times 180 degrees over pi to give you some approximate degree answer. But I don't know what it would be because I don't have my calculator. Sorry about that. All right. See, somebody's typing. All right, good question, because especially if you're coming from Algebra 2 Trig, my students, I've hammered it into them, but if you're coming from Algebra 2 Trig, that stupid book referred to theta in degrees and then x in radians. So your Algebra 2 Trig book said, if you see theta, then it's in degrees, and if you see x, it's in radians. He was a lazy author. Very smart. If you're writing a textbook, you're very smart, okay? But that is the only book in the history of math that I know of, and I've read a lot of math textbooks that uses that. Nobody else does that. So, theta is an angle. It could be in revolutions. It could be in degrees. It could be in radians. Any of them, right? So theta is just an angle, and we can use any letter to represent the angle. We can say theta, we can say beta, or alpha, or phi, or I don't know. I think you guys have pretty much only seen theta so far, but it does not just mean degrees. It is just an angle measure, and what we'll say to you is if we want an answer, so like on the quiz on numbers 17 and 18, we let you know which mode you should be putting in your calculator, because 17 says, hey, theta is between 0 degrees and 360 degrees, versus number 18, it says, hey, theta is between 0 and 2 pi. And so this one, you need your answer in degrees, and this one, you need your answer in radians. So good question, Samantha, because I don't know if your other teachers have mentioned that, versus if you're coming from Algebra 2 Trig, it was like ingrained in you that theta meant degrees. That is not the case. We let you know. All right, I'm going to call it a night. I will post the recording in the little chat window. And